Some series and integral calculus. Some series and integral calculus, very historic discussion we are pursuing. Can we calculate some series through integral calculus? This is something that would change many arenas, and primarily it is based on how we can convert a discrete function into continuous function. Okay, this is extremely important. Discrete function in the continuous function. This is primarily important in arena of probability and statistics, mainly in artificial intelligence scenario, where people have kind of discrete like probability. Okay. What can you give some real life example? Real life example is very simple. Many times I have given. Okay, what is real life example? Consider consider that there is a class and there are n number of students. N number of students are there and in a class. Then I'm trying to draw a distribution of marks among the students. Means there was an examination and students got 0 to 10. 10 is maximum, 0 is minimum marks in the class. Now among the student, now I'm making x-axis and y-axis. Okay, this is x-axis, this is x-axis, and this is y-axis. This is y-axis. This is x-axis. If that is the scenario, if this is x-axis and this is y-axis, this is origin. So x equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Make sense? Now, against 0 marks, how many students are there? This is the number of students. Divide by n. N are the total number of students in the class. If number of students have received 0 mark or 4, then this height is 4 by n. Means all heights are less than 1. 4 by n. At x equal to 1, what is the height? At x equal to 2, what is the height? Consider at x equal to 10, against 10 mark, 20 students are there. Then this bar chart height is 20 by n. Okay, if I add all the vertical, then it will become 1. It will become 1, guaranteed. It will become 1. This is called point mass function, probability distribution in discrete function. What is discrete function? If I connect all the vertical, okay, here I have a kind of students, number of students at x equal to 0, x equal to 1, x equal to 2, like so. If I connect all the vertical point of the vertical bar and draw a line, that is called a function, and that function is typically called distributed function or point mass function. This is a discrete function that is connected. Suppose that number of, if I don't divide by n, consider I don't divide by n, the number of students at x equal to 0 is 0. Number of students at x equal to 1 is 1. Number of students at x equal to 2 are 4. Number of students at x equal to 3 are 6 are 9. Number of students at x equal to 10 are 100. If I connect all the point and if I draw a line, then it will come into equation as fx equal to x square. Fx equal to x square. Make sense? Okay. Fx equal to x square, or if I'm dividing by n everywhere, then fx equal to x square by n. Okay. If someone adds all the count means x equal to 0 is 0, x equal to 1 is 1 by n, x equal to 2 is 4 by n, x equal to 3 as 9 by n, x equal to 10 is 10 square is 100 by n. If I add all, it will become exactly n number of questions. I'm sorry, it will become exactly 1. Okay, can I do any computation over this function? Not, we cannot do. Okay, tell me how many tell me what is the total summation. Yeah, total summation is 1. If I divide all the vertical with n, total summation is 1. Can I convert it to a continuous function? Okay, if I consider, I convert this into a continuous function, gx. If this is fx, fx equal to x square, then I convert into gx. Gx is a continuous function. What do you mean by continuous function? Continuous function means we have a y value, vertical value at any x, any x. Otherwise, if this is fx, then I have y value at x equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like so. Okay, but if I convert into a continuous function, then at any x I have vertical. Then there are so many x. Then examination happened with so many x. No, the marks was granted to the student in whole number only. 1, 2, 3, 4, 5, 6, 7, 8, not 1.1 or 1.2 or 1.3. This is the practical I am talking. Maybe in some school would be like it, but in this school, number has been granted to the students in 1, 2, 3, 4, 5, 6, 7, 8. In that matter, this is x equal to, if I convert into continuous function, then this is gx. But gx is a continuous function, not like a fx. Fx is a discrete function, means this is a rough graph. Actual graph is points only. You connect the point, it becomes graph. But gx is a continuous function and this is the actual graph. Then tell me what is gx? Yeah, the speciality of the gx is I want to calculate the number of students at x equal to 5. Tell me when how many students got number 5. Tell me. Okay, if it is a discrete function fx, then at x equal to 5, I have to measure the height. And then I'll tell these many students have received number 5, 5 number. Calculate the vertical. If I talk about the gx, then you have to calculate area. If there is a continuous function, then vertical will not make much sense. The area will make sense. That is called continuous function. This is also called density function. It is a density. To calculate the actual amount in the density, you have to multiply by something. So between x equal to 5, someone can calculate the area between x equal to 4.5 to 5.5. Whatever area is coming between 4.5 and 5.5, this area will be actually the number of a student at x equal to 5. Makes sense? What do you mean? The way you are talking, it looks like if I compute the full area, it will be 1, because total number of students from here to here is 1, because it is divided by n. Yeah. If I calculate the area, means gx dx from lower limit to higher limit 0 to 10, it will be 1 only. Okay. Whereas fx, if I sum all the verticals, then it will be 1. This is the relationship between the discrete function and continuous function. Discrete function, whatever we are seeing by adding the all the vertical in discrete function, that will be exactly same if I have a continuous function and I calculate the area. The way you are saying looks like continuous function is a density function, density over the discrete function. True, very much true. Okay, like if I say that what is the weight of something, that at x equal to 1, what is the weight? What is the weight? I mean, there are students in the class and I'm trying to calculate weight of each student, and then weight will come in whole number only. Weight of a student, this correspond to 50 kg. Okay, weight of a student 50 kg, 60 kg, 70 kg, 80 kg, 80 kg, 90 kg, 100 kg. These are the weight of a student. Against 50 kg, how many students are there? Against 60 kg, how many students are there? This is called discrete function. But if I have a continuous function, then if I take any point here and calculate the vertical, then I say at this weight, these many students are there. Wrong. That is what I am saying. That is wrong. If I want to know how many students are there at 60 kg, then I have to calculate integral from 60 to 70 or 55 to 65 or 50 to 60, whatsoever. In 10 kilogram, I have to calculate the area, and that will be number of students. So since we are calculating area, vertical multiplied by the width, This line is called density function because to have the actual number, I have to multiply by the width. This is called continuous function. But since it is a continuous function, calculus can operate on it, where on discrete function, calculus cannot operate on it. And that's why we are not talking about summation series, sum series, where we can think about calculation of the, we can think about the calculation of the sum series through integral calculus, calculating the equivalent of a discrete function as a continuous function, then we can proceed upon. I believe it makes sense. Anyway, what we have in our bin now. So in our bin, we have a summation that is 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus what plus. Okay. If I say number is 11, then it is sixth number. N equal to 1, n equal to 2, n equal to 3, n equal to 4, n equal to 5, n equal to 6. When n equal to 6, the number is 11. N equal to 6, the number is 11. 1, 3, 5, 7, 9, 11. Okay, if it goes up to n numbers, then what is the number at position n? At n, then it is 2n minus 1. What is the number at position 1? 2n minus 1, 1. What is the number at position 4? Then 4 into 2 minus 1, 7. 1, 3, 5, 7. Makes sense. What is the number at position 11? Then it is 11 into 2, 22 minus 1. That will be 21. At 11th number, it will be 21. Okay, thank you very much. Can someone calculate the summation that is 1 plus 3 plus 5 plus 7 plus 2n minus 1, where n are the number. Now we will go through. So we have talked about two ways to calculate this. One way is repeated summation. Repeated summation means we know that if it is 2 plus 2 plus 2 three times, 2 plus 2 plus 2 three times, I can write it as 2 into 3. 2 plus 2 plus 2 can be written as 2 into 3. Can be rewritten as 2 into x, where x is 3. Can be rewritten as function over x into x, where function over x is 2. Can be rewritten as function over x dx. Function over x dx. Okay, function over x dx, where limit is 0 to 3, where a function over x is 2, means 2 dx 0 to 3 will give the complete picture, that will come as 2x 0 to 3, 2 into 3, 1. Means repeated summation means if I have to add same number again and again, I can calculate through integral calculus also. First turn into multiplication and then into integration. What we have now, we have 1 plus 3 plus 5 up to n number, n count. Let's divide into n different parts. First part is 1, second part is 3, third part is 5, like so. If like so, then how many parts, how like so, then can each part behave like a same? No, all are different. One is 5, one is 1, one is 3, one is 5, one is 7, like so. Okay, okay, I can think about something. What is that? That is 2x minus 1. All I can write as 2x minus 1. 1 I can write as 2x minus 1. 3 I can write as 2x minus 1. 5 I can write as 2x minus 1. You mean, someone would say, you mean 2x minus 1 plus 2x minus 1 plus 2x minus 1 up to n times. Yeah. So I can rewrite as 2x minus 1 bracket close into x times. 2x minus 1 can behave as a function over x. Function over x into x. Function over x dx from 0 to n. 2x minus 1 dx. Okay. If I compute integration, it will become x square minus x, 0 to n square minus n. We got the result. N square minus n plus some constant. But these are the variable depending upon n. We will try now. If n equal to 5, then if n equal to 5, the number will go 1, 2n, number will go up to 9. 1 plus 3 plus 5 plus 7 plus 9, how much it is? Okay, it will come as, I believe it will come as 1 plus 3, 4, 4 plus 5, 4, I'm sorry, 1 plus 3, 4, 4 plus 5, 9, 9 plus 7, 16, 16 plus 9, 25. It will come as 25. If I take n equal to 5, it will come as 25. But here it is n square minus n. 25 minus 5, it will come as 20. Okay, so this is not the perfect solution. Why we are lagging in getting the perfect solution? Anyone would fire this question immediately. Okay, the way you said repeated addition would give the perfect result, then why you are not able to get perfect result? Why 5 less? Let's try n equal to 6, then n square minus n, 36 minus 6, 30. Whereas actual answer is up to 25, up to 5 it is 25, then plus 7. That will come as, plus, up, plus 11, 36. The actual result is 36. If n equal to 6, then net summation is 36. Whereas we are getting net summation as 30 only. Okay, n square minus n, 36 minus 6, 30. Wanted result is 36 and we are getting 30. 36, 30. Wanted result is 25, we are getting 20. We are getting less. First we'll understand why we are getting so. Why we are getting less. We are getting less. Let's see what's going on. This this is x-axis, and now we have at x equal to 1 we have 1, x equal to 2 we have 4, x equal to 3 we have 9, x equal to 4 we have x equal to 1 we have 1, x equal to 2 we have 3. Yeah. X equal to 3 we have 5, x equal to 4 we have 7, x equal to 5 we have 9. Verticals are like that. Okay. Now if I take it as a function, then all the top points I have connected through a line, and this line exactly talks about the function. Okay. If this is a function 2x minus 1, when x equal to 5 then it is 9, when x equal to 4 it is 7, when x equal to 3 it is 5, when x equal to 2 it is 3, when x equal to 1 it is 1. This is a function that I got by connecting the top point of vertical bar, and this is 2x minus 1. If I do 2x minus 1 dx integration from x equal to 1 to x equal to 5, to x equal to 1 to x equal to 5, okay, then we are calculating the area underneath it, and it is coming as n square minus 1, that is coming as 20. Whereas if I am calculating the verticals, let's consider calculating the vertical in terms of area. Is it possible? We'll try so. When x equal to 1, I have a vertical of 1. Okay, I have a vertical of 1. At x equal to 2, I have a vertical of 3. Okay, can I write 1 plus 3 plus 5 plus 7 plus 9 as same as 1 into 1 plus 3 into 1 plus 5 into 1 plus 7 into 1 plus 9 into 1? Yeah, why you are saying like that? Because if I say 1 into 1, that is the gap between two numbers. First number is at x equal to 1, second number is at x equal to 2, third number is at x equal to 3, x equal to 1 and x equal to 2. If I take this gap, if I multiply height 1 by this gap 1, then this gives the area of this rectangle. So if I calculate x 2x minus 1 integration, this is 2x minus 1 integration, the top side is a curved side and bottom side is a flat side, flat line, horizontal line. This area we get. But if I do the vertical addition, then first we get area of this one vertical multiplied by this rectangular region, we get the area. Then second, 3 vertical, and then this rectangular region we are getting. Then this rectangular region we are getting. then this rectangular region we are getting. Actually, we are getting addition of all rectangle. When we are doing the numeric addition 1 plus 3 plus 5 plus 7 plus 9, or 1 into 1 plus 3, 2 into 3 into 1 plus 5 into 1 plus 7 into 1 plus 9 into 1. This rectangular area we are getting. Where we are lacking. If I take x equal to 1, then this is the rectangular region we are getting. But here at x equal to 2, the height is 3. X equal to 1, height is 1. Means this triangular region we are missing in the calculation. This triangular region is in calculation is coming more if I go through integration of continuous function 2x minus 1 as a continuous function. But if I add vertical, then first it gives the area of this rectangle, then area of another rectangle which has a height of 3. Then someone will fire question immediately. Then integral calculus area should be more than vertical, but integral calculus area is coming as 20, where sum of vertical is coming at 25. Yeah, true. The where we are lacking is we are calculating the area between x equal to 1 and x equal to 5. That height is 9. Between this we are calculating the area. But if I am calculating the vertical area, then at x equal to 1 I have this rectangle. X equal to 2 I have this rectangle. X equal to 3 I have this rectangle. But up to, if I calculate area by rectangular area by, when x equal to 5, then I have a height of 9. Then we are calculating the last rectangle as this we are missing, because when we are doing integration, we are integrating from 1 to x equal to 1 to x equal to 5, that is height is 9. But in area computation, vertical area computation, rectangular area, the last rectangle, that is 9 by 1, this area is very big and that is coming extra. Someone will say, oh, understood. So one area we are missing. Okay, then can we try something like, we are trying integration from 1 to 5. 1 to 5 means n square minus n, it came as integration of 2x minus 1. Yeah, true. N minus n square minus n. Can I take, it's a game of limit. So can I take our limit from 1 to 6, one more, then you will jump the result. Then you are getting more than, because everywhere triangular region you are anyway you are getting more, and last triangular region you will get again more. So it should become more than it. Okay, how much more? N is, we are taking instead of 5, we are taking 6 now, one more. Integration from 1 to n plus 1, 1 to 6. If I try like this, then it will of integration from of 0. We had started with 0 as per the repeated. So 0 to n we had taken, we have to take 0 to n plus 1. 0 to n plus 1. 0 to n plus 1, how much it will come? Okay, n plus 1 is 6 now. So 6 square 36. 36 minus 6. It will come as 30. Actual result is 25. We are getting 5 more. Why we are getting 5 more? Because there are 5 triangles for which we are getting area more when we are doing the integral calculus. Let's take the first triangle. When x equal to 1, then height is 1. When x equal to 2, height is 3. Okay, if I talk about this, this is a straight line. This is not a curved line the way I am showing here. This is a straight line. Why it is a straight line? Y equal to 2x minus 1, dy by dx equal to 2. Means everywhere the tangent is 2. It is a constant. So it is a straight line. It is not a curved line the way I am. Okay. It should behave like the way I want. Okay. So it is a curved line. Guaranteed. So it is a curved line. Up. Okay, let's take all the triangles. So if x equal to 1 and x equal to 2, 2 height is 3 and x equal to height is 1. If I take this gap height is 2. The gap is 2 and width is 1. What is the area of triangle whose height is 2 and width is 1? 2 into 1 by 2, 1. Let's take between 3 and 5. Gap is 2. Gap is 2 and width is 1. Means 1, 1, 1 I am missing in each quadrant. So 1 to 2, 1 missing, 2 to 3, 1 missing, 3 to 4, 1 missing, 4 to 5, 1 missing. Up to 5 only we are doing. So 5 to 6 again one missing. So 5 we are missing. And that's why if I compute the area underneath it, it is coming as 30 if I take n as 6. And where n equal to 5, actual is 25. 5 we are missing. If I take n equal to 5, in area computation it is coming 20, where actually 25. Again 5 we are missing if I take one behind. So this is something that is minutely if we compute. Okay, no one would tell this much. Anyway, okay, let's try, someone would say, let's try zero point 0.5 to 5.5. Means both sides will take the limit, zero point 0.5 to 5.5. Then what it will come? N square minus n. What is zero point 0.5 whole square? That is 0.5 means 11 by 2. 0.5, 5.5 means 11 by 2. 11 by 2 whole square minus 11 by 2. Okay, that will come for the 11 by 2. Lower limit I am taking zero point 0.5. Someone can compute. It will come in same fashion, similar to like that. Okay, so is it what the means whatsoever? This will not be perfect. Why this is not perfect? Because the both area computation are different. If I take integral calculus, then we are calculating this area considering this same height as what we are taking for the discrete function. Discrete function, whatever height we are taking, discrete function calculate the height addition of all the height. If gap is 1 between two verticals, then roughly we can think about a area of a rectangle. Then this rectangular area is different than extra what we are getting through integral calculus. Both are different. Okay, what is another solution? This is fx. Can I go with another function called gx, new function completely? Fx is a function of discrete function, that is fx equal to 6. Ff or height at x equal to 6 is how much it is? 6 into 2, 12. 12 minus 1, 11. At x equal to 6, it is 11. The height is 11. X equal to 5, the height is 9. X equal to 4, the height is 7. Like that. This function is called fx. We are trying summation x equal to 1 to n fx. Summation x equal to 1 to n fx. This is what we are trying. Means fx plus fx plus fx plus fx n times. This is what we are trying, where x starts with 1. What is fx? Fx is 2x minus 1. This is discrete function and n number of times we are trying to add it. Can it be same as if I take another continuous function or density function and integrating the density function from one lower limit to higher limit? Means summation x equal to 1 to n fx equal to limit, lower limit to higher limit gx dx. I have to find gx. What is the continuous function? What will be the continuous function against which if I calculate the integration from lower limit to higher limit gx dx, the area will be exactly same as number of vertical we are adding. Can we find a continuous function in that manner? The way we talked about the probability density function at the beginning of the session 1. Okay, at the beginning of the whatever we are talking. Okay, in that fashion, can we find a continuous function for which integration from lower limit to higher limit will give the area, and that area will be exactly equal to the summation of all the verticals? Is it any continuous function exist in that manner? That is the question. Not to have that, let's consider this is fx. This is a straight line. This is what repeatedly I am saying. This is a straight line, that is fx. If this is fx, then we have, if consider I'm trying to add three numbers. One is 1, next is 3, and next is 5. Then it makes two sub area. One sub area, second sub area. Let's consider that for each vertical there is a corresponding sub area. If vertical is 1, then there is a corresponding sub area between 1 and 2, and that corresponds to vertical 1. There is a sub area correspond to at x equal to 2, that is height is 3. For height 3, there is a sub area that is right hand side of this x equal to 2. This sub-area belongs to height 3. This sub-area belongs to height 5. Makes sense? At x equal to 3. So there are three sub-area. Last sub-area belong to height 5. Second sub-area belong to height 3. And first sub-area belong to height 1. Three sub-area are there. Okay, now this sub-area, it go and hit fx. That I don't want. Because fx, there is no continuity. Let's consider there is another continuous function called gx, and all three sub-area, they go and hit gx. If I add all three sub-area, then how it will be? 1 to 2, x equal to 1 to 2 gx dx, plus x equal to 2 to 3 gx dx, and last one, x equal to 3 to 4 gx dx. First one area correspond to fx at x equal to 1. Second sub-area correspond to fx at x equal to 2, that is 3. Third sub-area that correspond to fx at x equal to 3, x equal to 1, x equal to 2, x equal to 3, that height is 5, that is 3 to 4, 2 to 3, and 1 to 2. If that is the case, then we can think about getting a gx. Then what will be gx? Consider that we have any x, and this is fx. Then at any x, fx is fx, that is 2x minus 1. If I talk about area, then between x and x plus 1, what is the area? Area that is going to hit gx. This area should be exactly same as the fx at x equal to x, because x equal to x, whatever the fx is, this height is being represented by this height at x equal to x for the fx is represented by the area gx at x equal to 1 to x plus 1. Both should be exactly same. Then only I can say my density function or continuous function between x equal to x and x equal to x plus 1 represent fx at x equal to 1. Make sense? Or x equal to x. If that is the case, then addition of all vertical bar can be achieved through addition of all sub area, where each sub area represents one vertical bar. Then summation x equal to 1 to n fx equal to 1 to 2 gx dx plus 2 to 3 gx dx plus 3 to 4 gx dx plus n to n plus 1 x equal to n plus 1, x equal to 1 to 2, 2 to 3, x equal to n plus 1 gx dx. Both will be same. In that manner, summation x equal to 1 to n fx will be integration x equal to 1 to n plus 1. Here it is x equal to 1 to n. Here it is x equal to 1 to n plus 1. Because area between n and n plus 1 will be the last sub area, dx dx. If I talk about only one point, that is x equal to x, then fx is 2x minus 1. 2x minus 1 equal to integration x to x plus 1 gx dx. People can think in this manner also. Or someone would say that rather than taking right hand side area correspond to the left vertical bar, can I take left hand side area to correspond to right vertical bar? That is also possible. In that manner, summation x equal to 1 to n fx will be integration 1 minus 1. 1 was the beginning earlier. 1 minus 1, 0 to n, not n plus 1, because we are taking left side. 0 to n g2x dx, because now gx will be different. g2x dx. Or can we try half left side and half right side? Someone can try. Then integration will be 1 minus 0.5 n plus 0.5 g3x dx, or fx equal to integration 1 minus 0.5 and top will be n plus 0.5. In second case, left hand side, full left hand side, it will be integration fx equal to integration x minus 1 to x dx dx, or g2x dx. We will proceed on this, and we will see all are same. If all are same, then we are fine in calculation, and then we will see that it actually hits the same result. If it hits, all methodology hits the same result, we have got the solution. That will, I'm really sweating. This is too intricate into calculus. how actually the inside of if people crack this kind of minute thing, then you can crack any differential equation or whatsoever, because this is the core of calculus. Okay, multivariable calculus. Multivariable means there are many independent variables are there, where you differentiate with one variable keeping all other variable constant. Or there are many dependent variables. Right now we have one dependent variable, that is function over x and gx. There are two dependent variables. Okay, there can be many dependent variable in a continuous manner only. In continuous we have only one dependent variable, that is gx. There can be many continuous in differential equations, especially like du differentiation of u by dx equal to differentiation of v by dy. Now we have two dependent component u and v, where independent component are x and y. How many independent components are there? How many dependent components are there? How many times we are deriving it? What is the order of differentiation? So this looks very cumbersome, but all falls in these minute details only. Anyway, please don't mind supporting us. +91 is the India country code 9483160610 is the telephone number. +91 is the India country code 9483160610 is the telephone number.